Okay, welcome everybody to our first video cast of geometry this year. So this is the way it's going to work. We're going to work through section 4.1 today. We're going to talk about triangles and angles. So we want to start off, just remind you guys, take notes, go through this. If you see examples and you need to stop, you can stop that, work through those. If there's definitions that you want to write down, make sure to do that. But just take your time going through this and make sure you understand everything you need to. Okay, so today basically we're going to start looking at triangles. We're going to start learning how to classify triangles by their sides and their angles, and we want to be able to find the angle measures in triangles. So the first thing we want to do is define what a triangle is. A triangle is a figure formed by three segments joining three non-collinear points. So two things we're going to do is we're going to learn how to classify these triangles by their sides and by their angles. So a lot of this will seem pretty similar to things you've done before in the past. But if you feel good with the definitions, you can just fast forward through them. If not, take your time and learn what's going on here. Okay, so classification by sides. So equilateral triangle, we have three congruent sides. Right now we're just classifying these triangles by their sides. Isosceles triangle, remember that's at least two congruent sides. So one thing about isosceles triangles are, the key word is at least, meaning you could have three congruent sides. If you have three congruent sides, it's still technically an isosceles triangle, but obviously an equilateral triangle as well. Classification by size, scalene triangle. So for scalene, none of these sides are congruent. Okay, for an acute triangle, now we're classifying these by angles. So notice the distinction between classifying them by sides and classifying them by their angles. So remember, the definition of an acute angle is any angle that's less than 90 degrees. So for this triangle, all these angles right here, they're all less than 90 degrees. Okay, once the classification by angles, we have an equiangular triangle. So this equi part right here starts seeming kind of familiar to a lot of you. Equal, you know it's going to mean these parts are equal to each other. So here we have three angles that are all congruent, meaning they're all the same measures. So we have three angles with the same measure. Now, if we have a triangle with three angles of the same measure, one thing else we can say is that not only do they have three angles of the same measure, but all three of these sides are congruent. Okay, right triangle means you have one right angle in your triangle. Obtuse, meaning you have one obtuse angle. Remember, definition of obtuse is an angle that's greater than 90 degrees. So anything above 90, we identify that as an obtuse triangle. Alright, so let's practice it. Let's classify these triangles by their sides and their angles. So I'll write angles up here, and then I'll write sides up here, so we can classify them. You can see what we're working with. So let's look at the sides. So we have one angle that's 50, one angle that's 110, and another angle that's 20 degrees. So we have one angle that's bigger than 90, so we have an obtuse triangle. Now the sides, let's look at the sides. None of these sides are congruent. You have 19, 16, and 23. None of those sides are congruent. So we call this a scalene triangle. So we would combine these two, and we have a scalene obtuse triangle. You could say that both ways. Obtuse, scalene, scalene, obtuse. I'm cool with whichever. Okay, let's classify this angle by the sides and the angle. So, right away, you see the 90-degree angle. So you know this is going to be some type of right triangle. Okay? And we have two sides here that are congruent. And we'll start talking about this relationship of 45, 40, 90 degrees triangles in different chapters. But for now, we know that we have two sides that are congruent. If we have two sides that are congruent, we know this falls under isosceles triangle. So we would call this a right isosceles or isosceles right triangle. Okay, so when it says to classify them by their sides and their angles, be sure to do both. Okay, so now we want to talk about vertex and adjacent angles. So when we're looking at a triangle, each of the 3 points joining the sides of a triangle, we call those vertices. So if I have a triangle right here, I'll call this one A, this one B, and this one C. So you notice that these two sides of the triangle come together right here at this point. We would call A a vertex. So adjacent side, similar to adjacent sides when we're talking about linear pairs. In a triangle, two sides sharing a common vertex. So I have my triangle here. I'll call this side A, side B, and side C. So a triangle with two common sides sharing a common vertex. So we would say A and C are adjacent sides because there's two sides sharing a common vertex. Okay, so here, for example, if I'm talking about angle A, this side right here and these sides right here are adjacent sides, and whatever this side is, we say that side is opposite of A. So be able to identify adjacent sides because we'll be using that in chapter 9 when we start doing some trig in this class. But for now, it's good to know it too. Okay, so if we're looking at right triangles, there's two components I really want us to get to know. So we have legs and we have the hypotenuse. So when we try to identify the hypotenuse of a triangle, you always want to look at whatever side is opposite of the right angle. And then after that, your legs are just the other two sides of the triangle. So when we're looking at a right triangle, we have legs and we have an hypotenuse. Okay. Okay, so for an isosceles triangle, for right now we're just going to assume that the isosceles triangle is equilateral. I know before I told you that it could be equilateral, but now we're going to look at the legs and the base. So this one's pretty easy to remember. The legs, just think about the legs of like a person. Those are the longest sides and the base is the bottom. So this is the third side and the legs are the two congruent sides. Okay, the interior angles. So when we're looking at a triangle, we want to know that the interior angles are the three original angles of a triangle. So interior angles are these angles in here. And we'll talk about some properties of these interior angles later on. But for now, be able to identify interior angles. And if we're talking about interior, you probably notice that exterior is coming along too. So exterior angles, we define them as the angles that are adjacent to the interior angles. So for example, right here, I'm just going to see if I can draw this in. Right there, that would be an interior angle. And then outside right here, this is our exterior angle. Once again, be able to identify and distinguish both of these. Okay, so for exterior angles, each vertex has a pair of congruent exterior angles. And when we're talking about vertex, it's where those two sides come and meet at a point. So each vertex has a pair of congruent exterior angles. So here's the exterior angle. Same thing this way. Here's that exterior angle. These will be congruent. And it's common to show only one exterior angle each vertex. So what I did here is uncommon. You probably won't see that too often. You probably will see something more along the lines of that. Okay, so right here we want to talk about the triangle sum theorem. So this is one of the most important and crucial theorems for us this year in geometry. When we're looking at a triangle and we're looking at the interior angles of a triangle, we should automatically know every time, shouldn't even hesitate. We should know that these three angles, no matter what, need to add up to 180. Okay, and one theorem we want to talk about exterior angles is the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So, for example, right here in this diagram, if we knew the measure of this angle and we knew the measure of this angle, we would know the measure of angle 1. So, for example, I'm just going to throw some random numbers. Let's say this was 30. And this was 35, we would know that the measure of angle 1 had to equal 30 plus 35. And the measure of angle 1 has to equal 65. Okay. Now, another thing we can notice that's interesting right now, we just talked about the interior angles of a triangle. We said that A plus B plus C would need to equal 180. So let's keep going with these numbers. We know that A is 30 and B is 35. And we'll leave C as is because we don't really know that yet right now, technically. But then if we add 30 and 35, we get 65. We subtract 65 from both sides, we get C needs to equal 115. Well, if this angle right here is 115, that makes sense because this is a straight line. And if this is a straight line, then what do these two need to add up to be? Good job, kids. 180 degrees. So, if you followed that, fine. If not, once again, guys, you can always pause these and keep going back and seeing what you missed. Okay, so let's do some practice problems now. So, let's look at this problem on the left here. So we're finding the value of x. So I know that this triangle, the sum of these interior angles need to add up to 180. So what I'm going to do is I'm going to say, okay, 3x plus 11 plus 4x minus 5 plus 90 need to equal 180. I know that these three angles add up together need to equal 180. We defined that theorem already. So from there, I'll just combine like terms. I'll get 7x plus 6 plus 90 will give me 96 equals 180. And then I would solve for x there. Okay, let me just erase some of this stuff. Give us some room. And once again, if you guys have questions on these, just write this stuff down. I'm sure the arithmetic you're pretty good with. We'll go over some of these problems in class if you have questions on them. Okay, so let's look at this next one here. Find the value of y. Okay, so let's remember the theorem for exterior angles. Remember, the two non-adjacent angles, if you add these two together, we're going to end up with this exterior angle. So what that tells us is 90 plus 50 needs to equal 2y. So same thing. Let's combine like terms. And this one's, I have enough room to do this math, so I'll write this answer out. So y would equal 70. Okay, so corollaries, we'll talk about a little bit more about what this word means in class tomorrow. But for now, let's just think about it as a theorem more than anything. So this theorem tells us that the acute angles of a right triangle are complementary. Now let's think about why that makes sense. This square right here tells us that this angle needs to be 90 degrees. Now what do we say the three angles of a triangle need to add up to be? If I have angle A plus angle B plus angle C, we know this needs to be 180. So if our diagram here, we don't know A yet, we don't know B, but we know C needs to be 90. So if I subtract 90 from both sides, I have A plus B equals 90. And that makes sense because if this C equals 90, whatever these two add up to be, they need to be 90. And remember, the definition of complementary angles are angles that add up to be 90 degrees. Okay, so let's find the measure of each acute angle. So, I know that this needs to add up somehow to be 180. So, I'll add up 2x plus x plus 90. I'll get rid of that 90, and I'll say 90 equals 3x. Divide both sides by 3. X equals 30. Are we done here? No. We got to plug this in here. So we know that angle A is going to equal 30 degrees. We know angle B is going to equal 2 times 30. It's a 60. Now let's see if this keeps going with our theorem here. So we have 60 here, 30 here, 90 here. 180. Boom. Okay, so let's sum up some of the ideas we learned today. Let's look at this diagram here. So in figure, we have segment PQ is congruent to segment PS, and PR is perpendicular to QS. So let's complete some of these sentences. So I'm actually just going to number these. Sorry about moving that. I'm going to number these 1, 2, 3, and then these two would be 4 together. Okay, so we know that segment PQ is the blank of the right triangle PQR. So if we look at our triangle PQR, we know that PQ is our hypotenuse. Okay, for number 2, we're looking at triangle PQR, and we know segment PQ is the side opposite of which angle? Okay, so a lot of you might be tempted to just say angle R. That is incorrect. We got to be specific, because angle R could be this one or this one. So we got to be specific about that. So when we're looking at this angle, we want to say that this angle is specifically PRQ, because that way there's no doubt about it, right? Remember, we said when writing angles, the one in the middle, this is our vertex. Okay, for number 3, we're looking at QS, which is this bottom right here, which is the base. So this is going to be the base of the isosceles triangle. And then we're looking at the legs of PRS, and I'll redraw it up here. It's getting a little messy. So the legs of PRS aren't going to be this one right here. That's our hypotenuse, because it's opposite of the right angle. So our legs are PR and RS. Okay, so once again, I said we talk about corollaries a little later. So if corollary is kind of iffy now, we'll go over more in class. But corollary to a theorem is a statement that can be proved easily using the theorem. So if you want to prove some of these theorems, you may need to add a line, a segment, or a ray to the diagram. Okay, and here's your homework. So this is actually, we won't be doing this homework. You won't be doing it now. Tomorrow in class, we'll go over the lecture, look at your notes, and we will do the homework together in class tomorrow, along with some other problems. And don't worry, the hot seat is not going anywhere, guys. We'll still be doing the hot seat every day, and quizzes every single day. So once again, guys, thank you. Once you go back and look at it, if there's anything that you need to go over more. But I will see you in class. All right, take care. Be good.